Last day of our diploma review, kind of scratch the surface of all our stuff. We're going to do 6 and 7 together, unit 6 and 7, so that's our trig functions and identities. So first off, we're just going to kind of review some of the important things to know about the unit circle. I'll just write the key values. So what I mean by key values is we got our 30, our 45, and our 60. So we know that's 30, we know that's 45, we know that's 60. In terms of radians, this is pi over 3, this is pi over 4, this is pi over 6, and then we know the points are root 3 over 2, 1/2, root 2 over 2, root 2 over 2, and 1/2 root 3 over 2. Okay, so those are just your key locations. Okay, the other thing I'll just write, just so that we remember our key points. So at 0 or 2 pi, it's 1, 0, 0, 1 at pi over 2. At pi, we're looking at -1, 0. At 3 pi over 2, we're looking at 0, -1. Okay, and then also don't forget your cast. So cast rule C-A-S-T stands for what's positive where. So cosine's positive in the bottom right, all for the top right, sine for the top left, and tangent for the bottom left. Okay. All right. Another important reminder, remember, x goes with cosine theta, y goes with sine theta for the ratios. Okay, if a couple people had breakthroughs last class, kind of scares me, but I'll say it to you guys too. Why? Well, the reason why is because if we choose the 45 and make the triangle 45, here's the angle. If you do SOHCAHTOA of this angle, opposite is the y value. So opposite over hypotenuse, that's why it's sine. So cosine, it's adjacent. Adjacent is the x value. So cosine goes to the x because of that. Okay? Oh, yeah. Okay? Haven't said that before, so I'm glad I said it today. So a couple other things here. These are just reminders. Okay? All right, so the other thing we'll talk about real quick is just the graphs of cosine and sine. I'll just draw them on the same graph just to be simple here. So we got a graph here. We'll say this is 1, this is -1. We'll just go simply pi over 2, pi, 3 pi over 2, and 2 pi. So remember your sine curve, we'll do sine in yellow. So sine starts at 0, peaks at pi over 2, comes back to 0 at pi, -1 at 3 pi over 2, back to 2 pi. So there's your sine curve. Sine theta. Okay, now we'll do our cosine curve. Starts at 1, hits 0 at pi over 2, -1 at pi, 0 at 3 pi over 2, and then back to the top at 2 pi. So this is your cosine theta curve. Okay. Yep. Okay, and then tangent. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so a tangent, remember tangent theta, just for a picture, has actually asymptotes because they have there's stuff that tangent can't be. So tangents, stuff it can't be, is at pi over 2 and 3 pi over 2. Well, why? Well, remember, tangent is y over x. So if I go y over x, 1 divided by 0 is here, -1 divided by 0 is here. That causes your problem, your asymptotes. Tangent also happens on a period of pi. Okay, so tangent graph looks like this. That. And then just straight there, and then it would keep going here, and then it would keep going here. But every pi over 2 is an asymptote for tangent. Okay, and then I'll just pause it here. So for Maddie here, exact values, it's not too bad. Okay, so the exact values. Okay, did I skip one? Oh, this is where things got messed up, I think. Yeah, so where is my, there it is. I need to move this to there. There we go. Okay, so sorry. It's right here. I just got a page ahead. I'll come back to that one. It's the next page. All right, so in terms of exact value is sine 300. So what is sine 300? So we got to know that 300 is a 60-degree reference angle. So that's right here. That's where 300's at. So sine of 300, you can see that's a bigger piece. That's negative root 3 over 2 there. So this right here is negative root 3 over 2 for your sine of 300. Your secant of 5 pi over 4. So first off, secant's cosine. So we're going to find cosine and flip it. 5 pi over 4 is also a tip that it's going to be a root 2 over 2, right? So 5 pi over 4 is here. And so that is going to be cosine of 5 pi over 4 is negative root 2 over 2. So secant theta, or secant of 5 pi over 4, is 2 over root 2 negative. If you rationalize, you're just going to get root 2. So secant at 5 pi over 4 is just root 2. Okay. The second example is like one that was on your final that you guys kind of struggle with. You got to remember when you're talking about unit circle stuff and they give you a point, you know the hypotenuse is 1, so it's a trig ratio. You're using your Pythagorean theorem to figure out that missing side. So y is missing, but it takes a couple seconds to find it. Okay? So whenever you get that, please don't freak out. So the point negative 1/5 y is on the unit circle in the quadrant 3. So that means that y is also negative, right? So that means we're over here. So we'll say this is negative 1/5 for being easy. Okay? And we don't know what y is, but we know that our unit circle is 1. So this is kind of what we're looking at. So that's negative 1/5. We got to figure out that side. So you'd go negative 1/5 squared plus y squared equals 1 squared. So negative 1/5 squared is 1 over 25. So I'm going to minus 1 over 25 to 1. So y squared equals 24 over 25. How do I get 24? Well, remember, 1 is 25 over 25 for common denominator. Then we square root. And this simplifies to y equals 24 breaks down to 4 times 6, 2 root 6 over 5. So we have y now. I didn't complete the question, but it did say we're trying to find cotangent. So for cotangent, we need x over y. So we have y now. Okay, so cotangent theta. And the other thing, too, I want to point out is when they say what's the value of cotangent theta, that means the ratio of cotangent theta, because they're not asking for degrees. They're saying what is the value or ratio at that point. Now that ratio is, remember, I know it's confusing, but that ratio is on the circle, whatever the radius is. But this being negative 1/5, we don't know how big the circle is, but we don't need to. Okay? Oh, sorry, excuse me. This one's on the unit circle, so yes, we do know it. But the point is that the ratio represents the value on the unit circle, like that distance. Okay, so we're not, like a lot of people think that when it says cotangent theta, you're thinking degrees. It's not. Okay, it would say find the angle measure theta. But anyway, okay, so this would be x over y. So we are negative 1/5. That's also a negative. Negative 2 root 6 over 5. It's negative over negative, which we expected because cotangent in the third quadrant is what? Positive. Okay, t. Okay, cotangent and tangent work together. So those both negatives cancel. The 5's also cancel. You see that? Those cancel. So it's really 1 over 2 root 6. And we're just going to rationalize. Huh? Nope. Negative over negative, that's what we were saying. Yeah. Root 6 over 12 is your answer as inexact. Okay. Any questions on that? Okay. Convert the measure 310 to radians. So we're just doing our quick conversion. So remember, angles to radians, we want a pi. So we go 310 times pi over 180. That keeps the pi so you have the radians there. You can fully multiply it so that it's a decimal, that's fine, but that's kind of how you tell yourself you're adding in a pi. If you're confused if it's pi over or 180 over. So when you do that, you get 31 pi over 18 if you don't simplify. And then if you get the decimal is 5.4 radians. Okay, couple number sense things I want you guys to get good at. What is 2 pi roughly as a decimal? 6.28. Right, 6.28, right? 3.14 times 2, right? 5.4 is just below that, right? Well, 300 is just below what? 360. So that 5.4 number should make sense in terms of the numbering of how your radians work around the circle, okay? So then, for example, convert the angle measure 1.6 radians to degrees. So where are we thinking 1.6 radians is? So if pi is on top for the radian, right? What divided by pi is just a little bit bigger than 1? Sure, yeah, like 2, whatever, it's close, right? So like we're kind of thinking along those lines. So Jake said pi over 2 is real close. Well, let's see what we actually get. Okay, if you go 1.6 times 180 over pi, you should get 91.7. So he's about right on. Okay, good. Okay, questions? Remember, it's still question time. I know you guys wore out. It's Friday. I get it. But still a good time to ask questions. So again, remember we talked about, we did this in the warm-up already. Arc length is in radians. So when you use the A equals R theta, that's a radian measure. So don't plug degrees in there. You'll get things way wrong. So don't do that. So determine the length of an arc that subtends an angle of pi over 5 at the center of a circle with radius 7. So we're trying to figure out the length of the arc at the pi over 5 rotation. The nice thing is they gave me radians. We have nothing to convert, okay? And they gave me radius. One thing I want you to understand, so like, well, let's just do this first. So arc length equals r theta. R is 7, theta is pi over 5. So we simply just multiply that, and we're done. Okay, that's the arc length. There's no problem there. That gives you 4.4. Again, I really like making the connection with the number sense. 4.4, why does 4.4 make sense? 4.4 is smaller than 7, which is kind of odd because an arc length of the radius of 7 you would think would be close to maybe being bigger, or even really close to that number, right? Because if you go around, if the circumference of a circle of 7 is 2 pi times 7, that's circumference formula, right? 2 pi r, that's what circumference is. And so my point is 4.4 is a really small piece of that. Well, it is because where is pi over 5 at? Well, let's think about our radians. Pi over 5, so if that's pi over 3 and that's pi over 4, that's pi over 6, it's right there. So pi over 5 is between 30 and 45. So yeah, it's a very small piece of an arc compared to the whole circle. That's my whole point. Okay? Sorry, probably a little more elaborate than you cared, but all right. So, oh no, I need to go back to this page. This is the next one, right? Transformations? Okay, my pages got mixed up. Okay, so next one. So now we're just going to talk about everything with our transformations of our sine and cosine curves. So just I'll write the kind of the standard. Okay, and then from that's our standard, we're talking about A, B, C, and D mean. Okay, so A means what? That stands for your vertical stretch or amplitude. Remember, amplitude can be found by max minus min divided by 2. Can get you your amplitude. And then I guess another thing, max is equal to A plus D. Min is negative A plus D. In terms of the letters up here, so A and then the D out here. Oh, that's not a times D, that's a plus D right here. Sorry. That's the vertical displacement. What's that? You can, but it's not. So, okay. Okay, so then B, that's your horizontal stretch, and that affects your period, right? Okay, and it's horizontal stretch by a factor of 1 over B. To find the period, it's 2 pi over B gives you the period. Tan is pi over B, yep. You can make a note of that if you'd like. tan pi over b. C is your horizontal translation. Okay, just left, right. And D is your vertical displacement. I like to say on this one, this sets the midline. So that midline, you have where you're at if you're on the x-axis, that's usually your midline. But if you up or down, you have a new midline to work from. So midline's what goes through the sine curve and cosine curve exactly in half. Okay. So then let's just talk about this one for this example in terms of everything it has. Okay, so this one has an amplitude of 2. You can call that vertical stretch too, but amplitude is a little bit more specific to sine and cosine. Okay, it has a horizontal stretch of 1/3 with a period of 2 pi over 3. So that means that curve's happening faster, which makes sense because it's a 3. Okay, just like when you have a slope line, right? If you have a slope of 3, it's growing faster. Okay, if you have a slope of 1/3, it's going slower. Yep, just like the one we had in our final. Okay, the horizontal translation, so we'll call it HT, is right pi over 3. The vertical displacement is down 1. I'll also make a note, your max, your min, your max and min of these curves. So if it starts at -1 is your vertical displacement, that's your midline. If my amplitude is 2, it's +2 minus 2 to -1. So 2 to -1, that means my max is 1, my min is -3. All right, and then a good one just to look at here just for future reference, guys. So like a couple things is that it says solve this right here. But as soon as you see something like this where 3x, we haven't dealt with 3x's. We haven't dealt with something like that. So if you kind of get into panic mode, okay, and that's a sine and a cos. Because first off, if we're trying to solve, we like them to have them be all a sine or a cos. We want to factor, or we want to find sines and like just all sine and all cos that I can solve. This case, that's not possible. We don't have triple angle identities. That's not part of what we're doing. So my point is that when you see this, you're like, whoa, 3x and plus, yeah, I'm going to go y1, y2 here and intersect. Okay, so y1, y2 here and intersect. Why don't you guys try that? Okay, I'll do it with you. I think I already have it in here. Y equals. Okay, so I'll go ahead and pause the video here. This is what you should end up getting, so I'll wait. All right, so then once you get here, you're going to set your second trace, intersect. I'm going to show you one thing that's kind of neat too. So this is also similar to your final question. We'll talk about that in a second. So enter. So there's my intersection. It's 0.94. Okay, so 0.94 is the first one. Okay, now the interesting thing about this one is that it does say on the question, it tells you to write in general. The general solution. Okay, so there's a couple things to do here. So we know it's 0.94 is the first one. We got to figure out plus what? Well, same thing you guys messed up before. Okay, that right there, see how it's a 3x? So that period is happening faster again. So instead of plus 2 pi over 3, you have to put instead of 2 pi, it's 2 pi over 3n. It's the same thing we messed up on the final with the 4x, remember? Okay, so since we have a period change, we have to change the general solution period. Okay, and another thing you can do that's really cool, I think, is that I can test this to see if it's right. How can I do that? I can go 0.94 plus 2 pi over 3, and what should it be? The next one over. Okay, so you could do that. All right, let's keep on going here before I lose you guys. All right, so what's that? Right, and so that's why it says general solution. That's what I mean, Maddie. So it keeps happening every 2 pi over 3, so we don't have to find all of those. Yeah. Okay. If Maddie, if it said find all the zeros between 0 and 2 pi, then you'd find all 3. Okay. Okay. So then, how do we isolate? So this is back to our trig equations and how we solve. So right here, I'm actually going to do this a little different than the last class, just because I think you probably should do this anyways. So I would caution, and we actually talked about this in the notes, I would caution dividing by cos x first, because when you cancel that out, you're actually canceling a 0 out. Okay, and why? I'll show you. So if I move this over, like that, now I take cos x out. So if you divide that off, you might have forgot to do that one. Right, because cos x is a 0. You guys see that? Because if I divided them off and then I solved, I would get the root 3 over 2, but I'd be missing this guy. Yep. Mm-hmm. Oh, yeah, sorry. That's a plus. Yeah. Thank you. So I added it over the group. Good. So your answers are cos is 0 and cos is negative root 3 over 2. That's what you're looking for. Okay, and it wants in degrees. It's between 0 and 360. Okay, so where's cosine 0? Cosine is 0 at 90, at 270. Where's cos negative root 3 over 2? 150 and 210. Okay, yeah, and if you're doing radians, it'd be pi over 2, 3 pi over 2, 5 pi over 6, 7 pi over 6. Okay? Any questions on that? Okay? So all I'm saying, if you do solve and you divide something off, you need to account for that being eliminated if you're solving. Okay? All right, so determine non-permissible values of variable in the trig identity. Okay, so determine non-permissible values. We're just doing non-permissible right now, so we're not doing the identity. We're going to do the identity in the next slide. Okay, but cosine sine theta. So you're looking at where is their denominators. So we have the denominator here, and then we have we're going to write this as what? Cos over sine, because these are both a problem, right? Because if 1, 0, you get 0 on the bottom, or you're dividing by 0, which is still a problem. Non-permissibles, we're simply figuring out what are the problems. So far on this sheet, your problem is when sine is negative 1, that's a problem. When sine is 0, that's a problem. When cosine is 0, that's a problem. And now you have to tell me where that's at. So if you do this, essentially, we can have cosine or sine be 0 or sine be negative 1. So sine's negative 1 at 3 pi over 2 or 270. You can go degrees. It doesn't say which one, so we can just do which one we want here. Sine is 0 at 0, 360, 180. And then cosine is 0 at 90 and then 270. So you can see you have 270 repeated, but simply you can see it happens when? Not pi, every pi over 2 or every 90. So all the corners are a problem. So you can write it 2 ways. You can say 90 degrees n or pi over 2 n. Those could be your general solutions there, because every 90 is a problem. And then we're going to prove that identity in the next slide. Almost done, guys. 3 problems left. Okay, everybody got that? Okay, so now prudence identity. So this sort of one you have to get a little creative. And what I mean by creative is that sometimes there's not a direct cancellation. So I would say that as soon as I read this the first time, I notice the 1 plus sign, I don't like it. Okay, because the 1 plus sign, again, I'm going to say this, and you're going to get mad at me. Please don't do this. No, don't do that. Can't do that. Legal in every country. Okay, so you can't do that. Make sure that you understand that. So the problem is that I really can't cancel or do anything with the left side other than times by the conjugate to the bottom. And the reason the conjugate in the bottom helps me is if I times the bottom by 1 minus sine square, or sine, that comes out to be 1 minus sine squared. And what does that turn into? Cos squared. And so when you see those 1 plus sines or 1 plus cosines, and you're not sure if you can get rid of them, I would think about the conjugate. Okay, think about how you can change those, okay? And the other thing that's kind of a giveaway is that this has a 1 minus sine here. So maybe using that's helpful, right? Okay, so we're going to go to the left side first. So we're going to times, so we're going to go cosine theta, sine theta, and we're going to times that by 1 minus sine theta. Oh, no, yeah, no, that's right. And then 1 minus sine theta on the bottom. We're doing the left side first. So that makes, and don't multiply this out yet, okay? So the top we're going to leave just as it is. I have little extra brackets here, sorry, but it's okay. And I told you 1 minus sine theta times 1 plus sine theta can turn into cos squared theta. If you don't know why, because if you multiply those, it gives you 1 minus sine theta, and by the identity, that is cosine theta. Or cosine squared theta, excuse me. Do you see why I didn't FOIL those out? Because I can cancel the cos off, because this is all a product. So what we have is, we have 1 minus sine theta times sine theta all over cos theta. Okay. Well, I have a 1 minus sine theta on top. On the right side, I have 1 minus sine theta on top. So to me, I'm going to stop here, because not much else I can do here. I can write sine over cos as what? What can I write sine as cos over if I really want? Tan. I could write this as 1 minus sine theta tan if I wanted even. Okay, now let's do the right side. Right side, immediately we're going to write cotangent as cos over sine. And when that's on the bottom, the top is like this, right? The 1 minus sine theta is technically over 1. So I can see I have the underachiever and the overachiever. So you kind of see it's coming to be the same exact thing. That's what happens. And you're done. Sine over cos can be tangent, 1 minus sine. And so you got the left side equaling the right side. Got to do the fraction with it, Maddie. So you have this right here on the top, there's no fraction with it, right? So we just write this thing over 1. Now cotangent's cosine over sine. So it's fraction over fraction. So when fraction over fraction, you got underachiever and overachiever. So cosine goes with the 1, the sine goes with the sine. And the cosine's by itself with the 1. And so that's how we got here. And then this is the same thing we had right here. And we just wrote sine over cos as tangent, so I just did sine over cos as tangent. Okay. You can do that because it's a product. Okay, you can do that because it's a product. Okay. All right. Now this one, I can see this being on the diploma, so wake up a little bit. I can see this being on the diploma because you would say, gosh, I can't solve that. It's cosines and sines. And I don't know, what am I going to do? I can't factor a sine and cosine. You need to change the sine squared. Every time you have a cosine squared or a sine squared, they can be changed to the other one. Okay? When you're factoring or when you're solving, this is a solving, you want it all be in the same trig, not identity, but same trig function. Okay? So what you're going to do is, you're stuck with cos x. I can't change a cos x. So I need to make them cos x's. So I'm going to say 2 times sine squared is equivalent to 1 minus cos squared. And I'm going to get to cos squared land. And now we are cos x plus 2 minus, 2 cos squared equals 1. And now we're going to work on solving this, and we're going to be using factoring. How did I get a plus? Sorry, did I write a plus something? Oh, yeah, so I put a plus here. Okay, yeah, I got you. Sorry. It's not all wrong, so I just over-erased. You're fine if you have. So it'd be cosine x, yeah, minus 2 times 1 minus cos squared. Thank you. Equals 1. So that's going to be negative 2. That's right. I was going to say this was a positive cos x squared earlier. So negative 2 plus 2 cos squared x equals 1. So it should be like that, sorry. So then we go 2 cos squared. In the front, just put it in order so we can factor. I'm going to minus the 1. Yeah. So I'm here. And now we're factoring that. 2 times negative 3 is negative 6. Factors negative 6, it is 1. 3 and negative 2. So 2 cosine squared x minus 2 cosine x plus 3. Man, pen is not working today. Please cosine x minus 3. So you factor out 2 cos. So you get 2 cos x. And that gets you what's left in here. Cos x minus 1. Take out a 3. Cos x minus 1. So you see your answers are, for the factors, 2 cos x plus 3 and cos x minus 1. So that means your answers are cos x is 1. Is that possible? Yep. Cos x is negative 3 over 2. Is that possible? No, it's bigger than 1, right? Our cos ratios can't be bigger than 1, so this guy is rejected. So your only answer is 1. Cosine is 1 at negative 2 pi, 0, and 2 pi. Why did I put negative? Because they told me to. That was my domain they wanted. Okay. Okay, last one. Yes, we'll pause. Okay, here we go. Okay, use the sum or difference, double angle identities. So this is the sum difference idea. Again, this is formulas. So it says determine the exact value of cos 165. So the problem here is there is no exact value of cos 165 on our unit circle. So you have to write this as a sum so that you can get the exact value. Okay, and so what you do is you're going to write it as cos, and there's other combinations you can do, okay, but cos 120 plus 45 is what we're going to do. Again, there's other combinations. You'll still get it right if you do a different combination. And so this is from your formula sheet. So we need to use cos of 120 plus 45. That changes to cos 120 cos 45 minus sine 120 sine 45. And we do this because we know those values. Those values are actually on the unit circle. That's why we did it. Sine of 120 is, or cosine of 120, excuse me, that's right here. So that is the negative 1/2. Cos of 45 is root 2 over 2. Sine of 120 is positive root 3 over 2. And sine of 45 is root 2 over 2. And now we just simplify these. So negative 1 times root 2, 2 times 2, so negative root 2 over 4, minus root 6 over 4. And so the end of it, that's your exact value. Okay?